Hi, everyone. This is Jay from Interview Query, and today I'm here with Andrew from DataLeap Tech, another YouTube channel, and also a coach on Interview Query. And today we're going to go over a mock interview on SQL. And so before we get started, I'd love for you, Andrew, to talk about kind of your background and a quick summary about how you got into data science.
Absolutely. First things first, thank you, Jay. He is one of a kind. I feel like there is not many CEOs out there helping this direct niche of people try to find data science interviews and master them at this level. You've built out a very unique product. I feel like I'm talking to someone I've looked up to for a long time. So awesome that I'm here. Thank you for having me.
Yes, the flattery is much appreciated, Andrew.
It's all deserved. Okay, so my background in data science is pretty diverse. Very nonlinear background, starting in natural language startups and then going into data engineering for a hedge fund, moving around into Silicon Valley, starting my own businesses, and ultimately ending up in fintech and crypto, where I currently reside. And I feel like there is a lot of academic research that can be done in this field, especially where natural language and fintech intersect. So that's the kind of data science expertise that I try to provide a little context, a little flavor to my mentees. But the kind of mentor that I am is one that tries to paint a picture with your candidacy. Every single mentee has a trajectory that needs to be told, right? And nobody is exactly the same. And that's what a lot of people don't realize about the interview process, is that when you go to a recruiter or a hiring manager, they're actually trying to sell you. They're trying to sell the package that you are to the person further up the ladder. So if you can have a good understanding of where you're coming from, where your strengths are, and where you can continue to challenge yourself, that's the kind of mentorship that we would undergo if we were to do a mentorship or a coaching session.
Awesome. Cool. And I think people are really excited to try to jump on that, as well as we've seen a lot more interest in just the different kind of learning styles within data science and getting people up to speed based on where they're at and just trying to figure out where they are and, if they can pass the interview and get that job as well. Cool. So now I'm going to move on to CoderPad as we go over the SQL question. Okay. So today we're going over the SQL question that's pretty standard, and it requires two tables that are pretty common: employees and projects, right? So the employees table holds all of the employees, and then the projects table holds all the projects that the employees could work on, right? And so the first question that we have is, take the 5 lowest paid employees who have done at least 10 projects. So Andrew, how would you tackle this problem?
Okay. I would say, so the first things that, before I do any code, is I would have to first ask about the nature of the tables and then maybe write a little bit of outlining in pseudocode before we jump in.
Okay.
So the first thing I want to ask is, would I be correct to assume that the employees table is a bit of a directory? So like a Rolodex that you would find on your contacts app, or a collection of every single employee that exists at this company?
Yes.
Okay. And then the nature of the second table seems like that it is more of a ledger. So something that only gets updated when a new project is in the pipeline. And any project that's never existed or isn't worthy of being in this table wouldn't even exist.
Exactly. Yep.
And then I have to think about how these two tables are related. So it seems like the employee ID in table 2 is the foreign key into table 1. Is that correct?
Yes.
Okay. In that case, I have a good understanding of the nature of these two tables, and then I can move forward. Communication, I think, is a big part of these kind of interviews. So
Yeah, definitely.
take the 5 lowest paid employees who have done at least 10 projects. Well, the first thing I would imagine is I would need a filter for employees who have done at least 10 projects. And then I always indicate to the interviewer that I have an understanding of how to filter this. So I would put in parentheses, this seems like an aggregate filter. So we would need having. And then I would need to take a ordered list of employees based on their salaries. So I would then order by salaries. This, of course, I have to do order by. And then 3, I would consider limiting this to only the 5 lowest paid employees, which means that I need to then limit. And then I would limit to the 5 lowest. Then I would go back to the interviewer. Either I talked out loud during this entire process or I didn't, and hopefully I did it really quick. And I said, interviewer, does this look like the 3 steps that I should take to solve this question?
Yep.
Okay, so then I would start coding. So let's get rid of this so we don't accidentally run it. The way that I would start, I always start with the select statement. And then I know a lot of interviewees get bundled into getting the wrong select statement for some reason. We have to verify what we mean by lowest paid employees. So we're selecting employee ID, and that's the only column we want to select. Is that right?
Yes. It looks like there isn't anything else that's identifying for the employee. So yeah, probably the employee ID.
Perfect. So then I would expect that we're going to alias employees as E. So then EID is all we're going to select. Where we're going to select this from? Well, we're going to select it from the employees table, whereas that's where E is. So you can put as E, or you can just put E. This is shorthand for an alias. And then we would want to join this. Now, what kind of join am I thinking of? Well, like we established, the nature of these 2 tables is that this first table is a ledger. So any employees that have done 0 projects wouldn't even exist in this table. But we need people who have a lower bound of 10 projects. So we don't need to do a left join. Let's just do an inner join here. Some people just go ahead and go like there, projects, right? Without really understanding what the comma stands there for. Make sure in most interviews, you want to be able to indicate exactly what kind of join you're using. Okay, so let's inner join projects, alias that as P, on E.ID equals P.employee ID. Okay, that's pretty simple. And then we're going to do our very first step, filter for employees who have done at least 10 projects. All right, that means that we need having, but before having, we need group by. So we group by, what are we grouping by? Let's group by the employee ID, since we're looking at how many projects each employee has done. And then we are going to have to do having. And this having is going to look at the definition of done. And I would go to interviewer and I say, does done mean that the end date needs to exist and is in the past?
Let's say that the end date does have to exist.
Does it have to be in the past?
So let's say that it could be in the future because we're projecting the end date of a project.
Excellent. In that case, I don't have to do a more complicated case when. I can just say having count of end date greater than or equal to 10. That way, we were counting each end date, and if it's a null end date, then we won't count that. So we're counting only end dates that exist for each employee that have end date greater than 10. And then we are going to order by. Let's order by their salary. This is P.end date, E.salary. Now, descending or ascending. Now, ascending means that the lowest salaries go first, so that's what we want.
Mm-hmm.
Ascending is also, of course, the default, but adding it doesn't hurt. And then we're going to limit 5. We want to make sure that this is correct. We did the first step, we filtered. We did the second step, we ordered by. And we did the third step, we limited. And it seems like that this is going to be correct. So then I would turn around and I'd say, I think this is good. Do you have any questions about what I wrote?
Yeah, I think it does look good. I would say for your having count statement right here, does it matter if you put in the end date or can you use any row? And if so, then why?
Good question. I would say that by the definition that I just established with you, if you put any other row, well, actually, you can only put these 3 rows, right?
Yeah.
Because employee ID is something that we're trying to group by. If you take any of these other rows, then you are risking the idea that sometimes project could exist. It could be populated with the ID, get populated with the start, but it doesn't have an end date. And in that case, we can't count it as the definition of done.
Gotcha. Okay, cool. That sounds good. Do you want to do a part 2 to this question?
Let's do a part 2.
I have an idea for a interview question just from this. Okay, let's look at the part 2 of this question. Essentially, in part 1, we looked at the number of employees by specifically lowest paid and then 10 projects. So the second part is, what is the sum of the salaries of employees that have not finished a project?
Okay, so now we go back to the definition of not finished. So in this case, I can already imagine that there's at least three different definitions of not finished.
Okay.
So let me define them here. Not finished definitions. The first way that a project could be not finished is that a project could have no end date. So the end date is null. The second way that a project could be not finished is that the end date is in the future. So that means that it is greater than current date. And then the third way that the project cannot be finished is that if it never happened at all. But if it never happened at all, we've established that the table 2 is a ledger. So therefore, if there is no project ID in table 2, or a better way to say it is there exists an employee ID in table 1 that has no project ID associated in table 2.
Okay. So given these three conditions, and it's good for you to lay this out, let's say that we're going with number 1, the end date is null. That probably seems like the most reliable way to collect data in this case, given how we kind of set it up. And then we can erase that idea of the end date in the future from question number 1.
Okay, what about number 3? If an employee has never had a single project assigned to them, then they haven't even done any projects. Or they can't finish a project if they've never started one.
That is true, but then they could have been assigned one and then not finished it, right? And we'd still want to record that somewhere.
Yes. I think that would be good. I think that would be covered by the first condition. If they had a start date but no end date, then their end date would be null.
Yes. Yeah, exactly. Yep. So, but if they have no project ID associated with the employee ID in table 2, then they would just have never been assigned a project to begin with.
Correct.
Right?
So you just to clarify, that doesn't fit this definition.
Yes. So okay. The definition is then, what are the sum of the salaries of employees that have not finished a project, but were assigned one?
Okay, let's get started. So I would select this time, and remember, always be sure what you're selecting. So I'm going to select sum of salary. Indicate that this is in the employees table. Employees. Now, incredibly important is that now we have to consider what kind of join we are using. So last time we were able to use an inner join, but this time we know that all of the employees who have never had a project would also be here, would be entirely excluded from the output. A project, if we wanted to include them, then we would do a left join, and they would exist in the final output, and they wouldn't have an end date. So therefore, we would be including them anyway. But as of right now, we don't want to include those people because we want to include only employees that have started a project. So this is, again, going to be an inner join.
Okay.
I could just copy it from above, but, get those fingers typing. Okay, so now that we have the join complete, we're going to now think about this condition, right? If we filter for end date equals null, we can do that right here. The problem with that is that it's going to take every single person, every single employee who currently has a project that they haven't finished. So let's say you have had 1,000 projects and your next project isn't finished. You would still be collected by this where statement. So your boss will say you're a slacker, even though the data scientist was the one that actually made the mistake. So we don't want to do that. So what can we do? Well, there's two ways we can overcome this problem. We could, one, having count of project ID equal 1. That means that they have only had one project ever, and that one project ever has end date equals null. Okay. But this doesn't collect the second problem, which is what if they've had 2 projects and they're both unfinished, if they're both in the future. So we now need to essentially filter all of the projects that they have that are unfinished and see if that equals their total number of projects. So this is going to get a little tricky.
Okay.
So 1 is actually not okay. We have to actually find out if having count of project ID equals the count of null end date. And this column currently doesn't exist, but what we can do is we could do a case when. So what we do here is we have either a CTE or a subquery, but let's do a CTE. So let's do with. Let's call this null end date. Actually, that's too confusing because I'm going to call null end date for the column name. So I'm going to call this CTE as. This is going to select the employee ID. Let's think about this. Let's only collect project ID. Let's do everything and then do a case when. So we're going to select star and then do a case when date is null, then 1, else 0, and from projects. Done. So this is going to give us the projects table, but with one additional column, which is this table. Let's call it as null end date. This is going to tell us exactly how many null end dates there are for each employee. So now, instead of joining to projects, let's join to this CTE. Still call it P though for a naming convention. And EID equals employee, P dot employee ID. And now we need to look at where having count project ID equals count null end date. We can't have having without group by. Group by employee ID again. We have the CTE include everything from the projects table except in addition to one additional column that tells us whether or not the end date is null for each row. And then we have sum of salary from employees, interjoin the CTE, group by employee ID, and having count of project ID equal to sum of null end date. We need that to be sum because this is ones and zeros instead of nulls and not nulls.
Gotcha.
This looks right. So this is the same idea as saying end date equals null, but this time it's saying how many project IDs do they have and how many null end dates do they have. If they're equal, then they're never finished the project.
Interesting. I had another idea for this one. I was thinking that if you did, let's say, all this stuff with the join, inner join on this one, potentially you could actually make it so that you grabbed all of the employees where they had a project that was finished. So it'd be like where e.id is not in, select employee ID from projects where end date is not null, right? So
I like that a lot. Now, I think the only problem with this is that it falls into the same trap as before, because let's imagine that you've done 1,000 projects. Well, actually, let me think about this.
Any of them, right?
Yes. Okay. So this is a condition for has done at least one project. Okay. No, I totally agree now. I have seen through the error of my ways. This is totally a legit way to go about it as well.
I think actually you don't even need this inner join on projects. Sorry. So, because then this would make it deduped, right? So now you would just select some salary like that, and that would
That's
get
the beauty of SQL.
Huh?
That's the beauty of SQL. You can do it so many ways.
Yeah, it is true. Cool. I have one last interesting question for you, but I don't know if we want to add it.
Oh, I do.
Okay. This one is like not as relevant, but I'll paste it up here. Let's say that it's time to give an annual raise
Mm.
to a few employees, how would you determine which employees should get the raise? And so it's a little bit ambiguous, but I'd love to understand how you might approach this problem.
I love ambiguity. So let's consider. Let's jot it down. This is starting to look like my desktop in terms of messiness. But let's just put some notes down here. So when we consider people who should get raised, that is an incremental, like marginal, right? Increase in compensation. And why do we usually give raises? Well, sometimes it's because inflation, right? Sometimes it's because the value of their salary is no longer matching the either the value of the dollar or the value in the market. But also it could, so since we can't look at this in these two tables, what we can look at is marginal increases in performance.
Yep.
When we think about who should get raises, we should really think about, well, what did they do last year compared to what did they do this year?
Yeah.
So what we could do is we could group by year, or depending on how often we give annual. So we could group by year and look at how many projects they have done per year, and then do a case win to determine how many people have done like a 5% increase in projects, 10%, 15%, 20%, all the way up to, let's say, 100%. If there's a considerable number of people that have done more than 100% increase in projects, then we could continue that case win. But I imagine that ultimately we're going to start thinning down the crowd until a couple of star performers are going to shine. And then what we can do is compare their salaries to star performers already, right? If projects is the only metric that we're looking at, then we would imagine that, okay, people who are getting paid more for doing the same amount of project increase, why is that? But then we should also remember that there is probably like a diminishing return in number of projects completed. So we might have to do some sort of penalty for people with a larger amount of projects, which is easy as doing another case win on top of that, which is for people who have done more than 100 projects and then 200 projects and then 300 projects, at a penalty that's like their increase has less weight than someone who is just starting out.
Yeah, so I would say there's a few factors here. You touched on one, right? It's projects. And then there's like project length, right? So like if you do 10 projects that are, a week versus one guy who does like 5 projects that are like a month long, then I would assume that the second one is maybe more deserving of a raise. And then to even add more complexity to it, it could be like how many people are on the project that you also did, right? Like, and, we don't have outcome of how good the projects are, but we could say that they're all equal weight. But, let's say that there are 2 people on this project versus like 10 people on this other project. And essentially, if you're assuming that all projects are equal, then the people who have done the 2 people on that one project have probably did better. That's kind of an interesting concept that we can maybe touch on. But yeah, in general, there's no correct answer, I think, but it's just about maybe for these types of questions of choosing one metric to calculate and then seeing if we could write the query for it, right?
Very cool. I totally agree. This is one of the questions that I love throwing out because I think a couple of like a trend I see in mentees is that they're very straight and narrow. Kind of like me back in the day, I really wanted to be like getting to the heart of the question as soon as possible. But then it's more of a conversation, I feel, is that you kind of want to give out your ideas and then open up to the coaching of the interviewer because they are essentially trying to lead you to the right answer in their own way.
So we don't have to dive into it though, because it seems like it'd be pretty long. All right, thanks for joining me today, Andrew. And if you want to check out more of Andrew's stuff, go to his channel on DataLeap Tech, where he'll be juggling SQL problems, Python problems, and more data science content for you there.
I appreciate it, Jay. Jay is the man. Subscribe to this channel if you haven't yet. Like this video. And if you want to make a 6-figure salary as a data scientist in 6 months, hop on over to my channel. I'll see you there. We have corgis.
All right. Bye.